Hello everyone and a very warm welcome to today's webinar here at Danish Sound Cluster, where we are treating acoustic design for multi-purpose sports arenas. Thank you very much for joining everyone. This is a session where we will try to understand the challenges and potential of collaborative initiatives of stadium and arena sound experiences where multi-purpose use for sports, concerts and live events is now a rising demand. My name is Jeppe Lindegaard. I'm head of branding, strategy and events here at Danish Sound Cluster, where we aim to unite sound people, to ignite new collaboration and to curate inspiration across the audio, acoustics and hearing industry, both here in Denmark but also globally. Now, thank you very much for joining. Now it's time to welcome our first guest in the panel, which is you, Klaus Toustrup. You can now turn on your video and microphone and say hello. You are architect, partner and owner at CF Møller Architects, a worldwide architectural studio founded and based here in Denmark. Now, you told me before we went on air here that you don't know anything about acoustics, but what do you know anything about? And can you say a couple of words about your presentation?
Thank you for inviting me. I mean, when I say that, it's of course with the respect that I guess a lot of people in your community is, really into deep dive of acoustics, where as architects, it's often more sort of a more soft touch to the acoustic. But the fact is, of course, that everything we do, creating space, is also creating, acoustical rooms. So my sort of focus is how can we actually, make a clearer understanding among architects. I mean, within my professional field, that one should collaborate even more with, the really skilled people into the acoustic world, because I think that will improve, of course, the performance of a lot of the spaces and buildings that we work on and with. So that's sort of my focus. And of course, for the theme, I'll get back to that in the presentation. So I think I'll leave that for now. But I think it's important that we actually get more sort of strings between the different professionals within this field.
Thank you, Klaus, and that's also why we are so happy that you wanted to join us here today, because, like you said, we know and meet an awful lot of acousticians, an awful lot of people who know an awful lot about sound and acoustics. So we appreciate that you want to meet us here today and take part of the conversation. Now, next in the panel, we have Dirk. You can turn on your camera and say hello.
Yes, hello.
Thank you for joining. You are the senior partner and co-CEO at WSDG. First of all,
that's me.
What does that stand for? Do you want to share that?
Yes, it's Walters Storck Design Group. Beth Walters and John Storck are the founders of the group in 1969, so a couple of years ago. I was 1 year old at the time. That's the history.
So you are an award-winning international firm specializing in acoustics and AV technology consulting and design, with offices all around the world, as I understand it. So where are you situated right now yourself?
Right now I'm on Saturn. No, I'm of course just kidding. But I could be. I'm in Switzerland at the moment, in Basel, actually.
Great.
My hometown.
Well, nice to have you with us. Can you say just a couple of words about what you will be sharing with us today?
Sure. I'm kind of adding on to Klaus' part. I want to share the consultant's view and some acoustical parameters, explanations, some vocabulary in acoustics domain, and also some of the actual process of working with a consultant, how that could look like.
Great. We're looking forward to that. Now, the final person in our panel today is you, Dominika Obwarzanek, Senior Application Engineer at D&B Audiotechnik, a worldwide company making sound solution for concerts, events and sound installations. And some of you who are based here in Denmark may also know you because you collaborate directly with some players here in Denmark, like Alpha Audio, and you're the owners of the Scandinavian distributor Ava Group. Maybe you can share a couple of words about your presentation today.
Of course. Hello, everyone. Dominika Obwarzanek, born and brought up in Krakow, Poland. Since 9 years, relocated to Germany to work as an application engineer for DNB Audiotechnik in their headquarters.
And what will you be sharing with us today in your presentation?
It doesn't come with a surprise that I'll be talking about the application point of view. So how do we make sure that we consider all the system components and integrate them all together, consider the room, consider all the pragmatic aspects, and how do we interpret the data or attempt to interpret the data correctly to make good decisions and choices.
Great, looking forward to that. So before I will leave the floor to you, Klaus, your presentation, I would like to share with you in the panel and you in the audience sort of the motivation for this webinar today. I had an experience myself that I'd like to share with you. I was attending a ball game in a brand new arena built, I think, last year or maybe this year. And I would like to hear, first of all, your initial reaction to this. Is just a photo of the roof construction. Any thoughts?
Well,
and I will share my own experience with you afterwards.
Well, I think, I mean, coming back to my first sort of point about sometimes when architects or entrepreneurs or people within the building industry is doing something, you sometimes wonder, did they ask the question, what is this actually for? And if it should be for an arena type of thing, is there then just one focus for the use of the space, or should there be several? Because if there should be several, then one have to think a little bit more about what you do with each building component, so to speak. I guess this place could be pretty awful if you just fill it with heavy amplified rock music, I guess.
Yes. Does any of you, Dirk and Dominika, want to add anything?
Honestly, a little frustrating. Sorry, Dominika, you go first. You're the lady.
Okay. I just have this metaphor in mind. I made a similar mistake lately. We ordered a couch online. We never really sat on it, and it turns out it's a beautiful couch. You can sit on it, but it's not the best part of the day. So it maybe you can make use of that, but it doesn't just suit the body type, or I don't know, the sitting depth and stuff like this. So again, the application part failed miserably. This is what I think.
And I would like to ask, why does this happen? Maybe you, Dirk, have a perspective.
It's as I just mentioned, a little frustrating. What I do see, though, there's also like a opportunity. It's pretty easy to fix this because there's a lot of void and kind of beams and stuff. You can easily get some stuff up there. I would say probably a budget issue. Let's put it that way, diplomatically. Maybe focus on getting the field of play right and the stands right and maybe the water system right, and then they run out of funds or something. I have no idea what the project is, of course, but this will acoustically not satisfy many functions. You see the loudspeakers, a lot of loudspeakers looks like it. It will be very exciting, acoustically exciting, the space, a lot of reverberation. Not a good situation. I probably go only once if I go to that place.
Right. Well, I can share with you that I'm not going back because it was so horribly loud, and the reverberation time was so long, and the intelligibility from the speakers was so bad. So they needed to tune them in the mid frequencies in order to hear anything. So it's just a big box of noise, and this was just for a ball game. This wasn't even for a concert, which they are also having in the plans to do. So that was just a motivation for this webinar. We need to fix this. So Klaus, can you please take over from here and share your presentation? I would just like to say that we have a couple of issues with Klaus's screen sharing, so please bear with us that you might see some gray boxes in the screen. I hope it's not too disturbing, but take it away, Klaus.
Thank you. Hopefully you see my screen now. So
yes.
And as Jeppe said in the beginning, and I've told him I know nothing about acoustics. Of course, it's not completely true, but it is important for me to stress that my perspective is from the architect's point of view. So I won't go into sort of the more technical detail, but more what have I experienced in some of the projects where we're working on, and where do I see that there are some missing links between what we do and what we supposed to do. Because I've had the privilege to work together with a lot of great acousticians and venue designers and audio experts. So I know the value that all of these great people create in a process if you invite them at the proper time. Because I think every person knows that, of course, that the acoustics shape our experience and the atmosphere of a space. So that acoustics is important. I think, of course, everyone experiences that on their own body. But when we design spaces as architects, often our focus is more on the classical building components, floor, wall, ceiling, columns, beams, structure, to create a space, to give it a tone with the materiality and placing doors and windows to bring in flow or daylight, things like that. That's sort of our typical focus. But we have a tendency to not always remember that the acoustics is also a component, and actually all the other elements is what creates the acoustic environment, both the positive and the negative impact in all kinds of spaces. And in CF Møller, where which I'm a part of, we have a long history of working with spaces where a lot of people gather, often to share an experience together. So, of course, acoustic is something that we are touching on in a lot of places. And when we have the overall topic about the multi-purpose arenas, we are currently working on both arenas, which is classical arenas, indoor spaces for concert and events, also pure multi-sport arenas for different types of sports activity, not for entertainment and musical event, but still there is an acoustic need in these spaces. Also multi-purpose stadiums. We're currently working on a new stadium in Malmö. And then we have worked on projects where it's both. It's both stadium and arena combined in one huge and also pretty sort of technical advanced type of building, like the Friends or now Strawberry Arena in Stockholm, where we have this big retractable roof where you can change the setting from an open to a closed roof session within around 15 minutes. So these places, these huge multi-purpose arenas, has of course huge demands in many aspects. The logistics, the sightline design, and of course also the whole acoustical part, because this is one situation and this is a completely different. It's the same room, but it's two completely different atmospheres you want to create. So, and in a space like that, it's also prepared for all other types of stuff. Much of it is about structural parts and about how to change things, how to change the surface of the pitch and things like that. But it's also, of course, a lot with the acoustical environment in such a space. And so, as Jeppe also mentioned in the beginning, there is a huge sort of evolution within the stadium and arena sort of world. Some things is getting more and more compact with many different types of events. Others are getting more specialized, like the Sphere, for instance, where the sport has sort of been left on the side, and it's more about events and entertainment. So I think one of the things that we try to do when we are working with these multi-purpose sort of facilities is asking, question for multi-purpose for what? Because something will actually help each other, support each other, like in the Spurs arena where football and NFL, that works pretty well together. Of course, I guess it's not the budget for every little sports arena in every little city, but it is something where it sort of helps each other. We have other types of multi-purpose arenas where the sport maybe not help each other, like football and athletics. But everything in the space is designed for maybe one thing is prioritized from another. So great sidelines for the athletic track means that the crowd gets very far away from the football pitch. And again, it also has an acoustic, an experience that will change in these kind of multi-purpose facilities. So it's important that we get very sort of good at actually asking these questions when a client or a developer would like to go into a field where they say multi-purpose. Because multi-purpose is not sort of a magical one-size-fits-all. And just a little example, which has a lot to do with acoustics, but it's not a normal sort of venue, but like a music house in Aarhus, where we have this great music house. It's a pretty big one, and it was designed with a multi-purpose hall, a roadhouse for touring theaters and music, but it was also the home of the city's symphony orchestra. And having a space which is actually quite full of resonance, or almost no resonance, because there's a lot of places with soft materials in order to host all other types of events, it was actually quite difficult for the orchestra to get the sound out to the audience. Meaning that they had to play really loud, a lot of hearing damages and problems like that. It was also a roadhouse, so they had to leave for other events during weekdays. So preparation was actually in a completely different acoustical environment. And this is, of course, not very satisfying for a deeply professional person. So in this case, there should be built a new building, which was purely for the symphony orchestra. And that was where I really sort of learned in the hard way that architecture is acoustic design. Every little piece counts. And not just the physical part of it. Acoustic is also about taste and emotion, colors, shape, materials. And for me, the acoustician here, which was Tateo, he was a translator between the artist and the audience and the client as well, to understand what is the sound, what should it be like. So that is the reason why you need to have acousticians to bring them in the process very early to actually understand and translate what is the ambition of this space. And in the end, this was the concert hall, where there was a lot of sort of things built in, shoebox shape, but no rectangular walls in order to avoid echo. A lot of different flexibilities built in, so you could change the absorption of the room, so that the room actually could sound like it was full of people, even that it was just a practice session. So a lot of these things was important in a concert hall. And I think all architects understand that when you design a concert hall, you need an acoustician, because you need to make sure that every bits and piece, whether it's in the ceiling or the walls or the balcony or the underside of the balcony, everything needs to be thought of carefully if you want to create a both beautiful but also well-functioning concert hall, which becomes part of the orchestra, so that the performer, the music and the audience becomes one thing. And for me, it was actually an eye-opener for later projects where we worked on arenas, because a lot of the ball design and the arena design has many similar themes. Of course, you don't want the same kind of resonance in a huge multi-purpose hall, but the areas that you need to treat are the same. So for me, I think it's important for us architects to understand that acoustic design is not something that you add on later. It is really deeply integrated into the shape and the materials of the stadium itself. So of course, there's a lot of stuff about sightlines depending on the arena type, the sport that you want to put there, or the type of event, and how you make that everyone feels that they are part of the event in such a room. But it's also a place where, if you're not being careful, you can have troubles about a lot of reflective surfaces that suddenly creates echoes and destroys the welcoming feeling of the space. And when you then turn on the music or the event, then you actually not able to actually be there and enjoy the session. Some of the areas that of course are critical are when you have the stands and the underside of the stands. That is places where there's a lot of potential build-up for a lot of noise, and where it can be completely horrible to sit if you're not careful and deal with these areas. The same thing about the ceiling and the floor. So the shape, again, if you have something where the focusing of the sound suddenly means that some areas are really being full of noise that are being focused on one point, then you have something which is difficult to control. And you can put in a lot of great speakers and stuff, but if the foundation on your work is something that is not really working, then it's such a difficult situation to solve. Of course, and this is something that we experienced when we were working at an ice hockey ring, because the sound of when they hit the puck is so important for the whole sort of environment and enjoyment of an ice hockey game, so that one shouldn't have a multipurpose hall where there's no reflected sound from crowd or from the sport itself. So finding that balance where you can still feel the crowd, you can sense the activity on the pitch, that is something that is, of course, important to balance. And to be honest, that's not something that we as architects can find that balance. It's something that, of course, needs to be carefully looked at and also calculated. So we want to have, of course, a more absorbent environment, but with cares and control and under control. A case study that we were part of, I'll show you here, a big project that has followed CF Møller for a very long time, is the Avicii Arena in Stockholm, which we were part of designing back in the 80s. And it's placed in a event city where you have a huge sort of multi-purpose stadium and arena, also one that can be covered. And you have an ice hockey arena next to it. And actually the globe was also built for ice hockey as one of the primary sports in that facility. It's a huge sort of dome, an enormous space, 85 meters from floor to ceiling. So a gigantic sphere. And before the sphere in Las Vegas was built, it was the largest sort of globe-shaped building. But the scale of the space is, of course, impressive, but it's also one of the tricky thing about it, because some of the sort of the bus from the audience and from the pitch just disappeared in this huge sort of space. So something needed to be done, because it was part of this whole event city, and the client can see that there's a development in other types of events. So sports was sort of being played a little bit down, and more concerts were asked for. So they set up a competition, and there was a tender for doing a renovation and modernization of this building, which is also listed. So you couldn't just do anything. And we were part of a huge and great team with a contractor, NCC and HOK, Slijk Bergman and partners, and Efterklang, which is a part of AFRI, were the acousticians on the project. And the main sort of topic was actually to change of course, there was a lot of basic modernization and changing some retractable seatings and things like that. But the main topic was also actually adjusting the acoustic experience in the space so that you could have some of the qualities from smaller arenas, a more intimate sort of feeling of the space, and of course a better acoustic solution. So the overall sort of component of the solution was some stuff being done in the ball itself by changing seats. There was some change of some of the lighting system and some curtain system that could adjust the acoustics. And then some new seating, gondolas, they were called, that were placed pretty high in the arena. A huge sort of ring that was part of the structural element that was connected to a superstructure. And within these two, there was this acoustic ceiling, which is an adjustable seating that also became part of the rigging for the arena. So here a little sort of a presentation of it. We have the gondolas that was put on top with some sky lounges for again part of the commercial part, a rigging structure, a new one, and then this new superstructure with a ceiling that has this adjustable system where you can both use the overside as a rigging platform, and then the underside is actually something that can change. And that meant that you have now a potential for changing the experience of the space. So instead of having this huge sort of dome on top of the seating and the pitch, you actually have this lowered ceiling that creates a more intimate atmosphere for some type of events. But you could also change it. So these panels, which is, of course, something that is part of both diffusing the sound, but also absorbing sound. So they can be removed. So you can still have that sense of the huge sort of dome-like space. So it's actually something where you can change the feeling and the acoustical environment with this new structure. And here a little sort of walkthrough. You have here in a situation where it's closed. It's put on a big grid where you can actually walk on these, like you can walk on the grid, and there's a net between it. So actually the whole surface on top of the pitch is now a rigging, part of the rigging system. Of course, prepared for sound system to be plugged into that. And then here over, we have the gondolas that is placed here. And I'll get back to that again, how some of the stuff that we did in the concert hall with, angling the different balcony fronts and things like that, all these elements is treated the same way here as in the concert hall. So again, here, this new ceiling that make the dome change, so you can have the feeling of the whole space, and you can actually also have a more intimate situation below. And Efterklang, who did the acoustic part of this, of course, did a lot of calculation about how should the functionality be of the retractable acoustic panels. How should they be sort of how much should they be able to change, and how many different configurations should they sort of help to service, and how would they be able to actually help distributing the sound within the space, as well as absorb space or sound from different type of events. Again, here you can see how these panels can be moved away so that you get the feeling of the big space, and you can also have this more dark space. So again, also to help the light setting and things like that for concert events. Same thing about as in the concert hall, that the walls is also treated very carefully with some places with absorbent materials, other places where it's like the underside of the gondolas. How do you treat that area so you diffuse sound and absorb sound in these areas that could be sort of full of noise if not treated well? So here a detail of the gondolas. See, there's these three-angled, it's glass sort of a balcony front, but they are all angled 3 degrees so that you don't get the echoing from side to side. And the underside is also treated with acoustic panels. So all of this is, of course, run through calculation. But to go back to your image in the beginning, Jeppe, some of this stuff is something that you often, also in a basic hall, you need to treat, a balcony front. So small things about remembering not to have just a 90-degree balcony front will help. And that's not where the cost is. I mean, you have to have it anyway. So it is things like that. I think it's important that we as architects is getting better at understanding in order to create great spaces that can also fulfill the ambition of having multi-purpose. So I would say my sort of, if I should give my advice to myself or to my own profession, it is that architects must remember that acoustic is a design driver. Acoustics create sound and space. So we should do it with the same care as when we are thinking about what the facade material should be or other areas that we often spend a lot of time on. And also that multi-purpose is a nice word, but it's not something that is easy to actually deal with. So it's important that we, together with other consultants, is really, really careful about asking the right questions about where is the potential synergy, where is there need for flexibility, and what should the compromise be. The symphony orchestra ended leaving the multi-purpose hall because they couldn't do their job in a proper way and the audience get a bad experience. So one need to ask the question, when is it better to separate things instead of trying to put everything into one space? And then the final one here is that acoustic design doesn't begin with the audio system. We as architects have a responsibility in understanding that the shape and the materials of a stadium or an arena itself is the foundation for making a great sort of experience of sound and acoustics. So we need to remember to involve acousticians and venue designers from a start. In the beginning in a screening process to understand the brief, or maybe develop the brief. And later on, of course, in order to make sure that all the bits and pieces, which is the basic components, is thought through in a clever way, so that you then can fine-tune it with audio systems and all the technical possibilities. So that was sort of my presentation. So I'll stop sharing here.
That was great, Klaus. Thank you very much. And I think there's a lot of acousticians in the crowd that are very happy to hear that they should be involved early in the process. With that, Klaus, I've seen a few questions coming in already, but we'll take them after the 3 presentations are done. So thank you for starting here, Klaus, and then I will leave the floor to you, Dirk. Please share your screen and begin your presentation. Dirk Noy, Senior Partner and Co-CEO at WSDG. Take it away.
Thank you so much, Jeppe. Also, Klaus, for your really, really cool presentation. I enjoyed looking at all the really clever acoustical solutions. I'm going to be a little more technical on my part. I'm going to focus on a couple of acoustic parameters, speech intelligibility, reverberation, sound pressure level, and then I'm going to explain a couple things about the acoustic design process, which you really did a good job on making people have an appetite for that, Klaus, I hope at least. Speech intelligibility. It may come as a surprise to some of you that we can actually measure speech intelligibility. It's an index called STI, and it quantifies how well a system transmits spoken language to a listener. And the scale is 0 or 0% to 1 or 100% from quasi unintelligible, you don't hear anything, to a perfect transmission of speech. The STI metric is based on a measurement of the modulation index. And you can say that simplified, how well does the system follow an amplitude modulation? Sounds a little complicated. I have a little graph and some audio to actually explain that a little better. You see here, the blue line is like, for example, a 500 hertz tone. Let's just keep that going, like, ooh, not sure if it's exactly 500, but I'm trying to do my best here. Ooh. And then the 500 hertz tone is being modulated in a particular way. It goes from max volume to 0, unaudible, to max volume again, to 0, to max volume again, in a certain frequency. So let's say 1 hertz. It means 1 time per second it goes up and goes down and goes up and goes down. It's like ooh, 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 approximately, something like that. That is done with a couple of frequencies, actually quite a bit of frequencies, both in the blue line and also in the red line. What we get at the end of this chain when we pass this through a system is something like this. You see that the blue line is never really going to touch the 0 level here, because there's the reverberation, for example, keeps some of the energy in the space, and so it will never really abate to 0. It's like more like woo. You still have a little bit of tone, even if it should be 0. There's still a little bit of tone left because the space is kind of keeping the tone inside it. And how good that is possible, how good the modulation goes, how well it goes to 0 and then up to 100 again and to 0 again, that is a measure for the speech intelligibility. We have 3 principal design strategies to achieve high speech intelligibility. I suppose it's clear that we have to have very high speech intelligibility in both sports arenas and also multipurpose arenas. So we have to keep the noise low, because low ambient noise levels, they prevent the masking of speech. We don't want loudness to be kind of over the speech, so it covers the speech. We don't want that. HVAC noise, for example, or traffic noise from outside. Second strategy is we have to control the reverberation, because when we have a short reverberation time, we can keep the successive syllables separated and they won't melt into the next one. And part of that is also a smart geometry that was really nicely presented by Klaus, also with the walls not being parallel in that one particular case study. And we also want to prevent echoes and focusing events on the ceiling, for example, the shapes of the surfaces. And the third one is we want to maintain a clean and well-distributed signal, properly focusing sound towards the audience. We want to deliver a clear, direct sound path, not multiple loudspeakers going to the same location, for example. And I'm sure Dominika is going to expand on that later on a little bit too. We want to avoid signal distortion so we can keep a high audio quality within the space. We want to focus on the middle section here, the control of reverberation. Let's quickly talk about what it is. It's the decay of sound in a space, and we see here like a chart that gives the reverberation time, recommended reverberation time, and here the utilization of the space. The multi-purpose audio zones we're talking about today is kind of this field here, 1.6, 1.8, maybe 2, a little bit, somewhere in this domain. For sports arenas, if we want to go just for sports facilities, we have a DIN, a German standard that we kind of observe in many cases. Given here, it's like a tolerance mask, so the reverberation curve should be landing within these upper and lower limits, basically. That's the goal for a sports facility acoustic design. We're going to take a look at the case study. I have prepared 2 case studies for you. This is a rather small arena. It's a handball arena in Switzerland, just opened a couple months ago. And this is the acoustical model. You see from above here, you see the ceiling structure, these beams. And within the design process with the architect, we had discussed 3 options of putting treatment on the roof. The ceiling is often a really good place in sports facilities because there's nothing else much happening other than technical infrastructure, but you cannot really do much with the seats because they're not in a concert hall, they're not going to be upholstered, for example. So treatment option 1, you see, it's kind of small fields within the fields that are given by the ceiling structure anyway. Option 2 is a similar size, but just differently distributed within the space, maybe a checkerboard type of distribution within the space. And the third option is we just treat the side fields with the treatment, and we also treat the beam areas, which also would be a nice idea, Jeppe, with the picture you showed at the beginning. Those trusses, they're easy to use for mounting of acoustical materials. We use the broadband absorber here. It's not really relevant which material for now, but these are the distribution patterns. And what we do then is we take a look at the simulations, the calculations that we can do before we actually build the place. And you see here on the right side the blue curve. That is what's happening in reverberation when we don't do anything. So empty space, no acoustical treatment. We have the blue curve way to reverberant factor of 2, actually 5 seconds almost at low frequencies. And then you see the 3 options from above, from before. Option 1, 2, 3 are the green, the orange, and the red curve. Almost all, actually all of them are pretty similar, and they all would be okay. So we told the architect, the architectural team, you can let us know which one you prefer. We can handle them acoustically. They're all pretty much the same. They also weigh very nicely inside the tolerance mask that we are given by the DIN standard. One more thing here is shown that you see that with the decrease, actually the increase of RT60 on the x-axis here, we are decreasing the speech intelligibility. Clearly, it's going way down, and it's going further down even when we increase the reverberation time even more. So it's really interesting and important to control reverberation to achieve high speech intelligibility. This is the arena. It's, as I mentioned, finished. You see at the ceiling here at the foreground, you see some of the fields that have been used with the acoustic absorber, and due to some value engineering, some of the fields had to be kept open, but most of the fields are covered, as was mentioned in the checkerboard option. Let's go to the last parameter we're going to discuss. This is a sound pressure level parameter. I'm also sure that Dominika, you're going to talk about that even more, but I just want to make clear that there's a correlation between sound pressure level and speech intelligibility. This is the Stadia Maracanã in Rio de Janeiro. I think, Klaus, you also showed a picture of this before the remodeling of the place. It was built in 1950 for the World Cup then, and it was remodeled for the World Cup in 2014. About 15 times the size of the small arena we just looked at earlier. So let's look at the speech intelligibility correlation with the sound pressure level. What is kind of a misconception is that the louder anything gets, the better we can understand it. That's actually not correct. On the right side, you see a graph that displays the sound pressure level on the x-axis, which is increasing, of course, to the right, and then the speech intelligibility, which is in fact going up at the beginning, which kind of makes sense. You have to have some level to actually transmit the sound and the speech correctly. But then after a certain point here at between 90 and 100 decibel, it's actually going down again. So this is maybe counterintuitive that the super loud systems, they are not going to deliver higher speech intelligibility at the end of the day. For this particular project, we did a study because the client didn't really trust that standpoint at the beginning. But we have here a speech intelligibility distribution on the right side of 110 dBA, which is really loud. It's close to the threshold of pain, actually. And we have a STI mean of 0.56. It's still okay because 0.5 is kind of the limit of most standards for fire safety. But if you go lower in sound level, 10 dB lower, we increase the STI by a little bit. And you see here the dark blue dots. There are more stands, there are more seats that actually have a better speech intelligibility than the solution above. So it's good to have a performing system, obviously, but don't turn it up all the way to 110 dB because we're going to actually reduce speech intelligibility. Then, last couple of slides, I want to discuss a little bit the acoustic design process, the collaboration, as also Klaus kindly pointed out, which is really critical in my personal opinion, the collaboration between the team, the architect, the acoustician, and the user of the place at the end of the day. We start with the definition of use cases and requirements. Often they're given for some instances, the IOC, International Olympic Committee, or the FIFA or UEFA for football, soccer stadia. They give target values for certain acoustical measures, but this needs to be discussed. What use cases do we really have? Like the concerts, like the sports events, like maybe we have a corporate event in the place, maybe we have gala dinners, who knows, and there may be a different set of parameters connected to those use cases. Second is assess the site and the building envelope. Are we close to an airport? Are we close to Autobahn, highways, etc., etc.? We need to just keep that in mind when designing the facade, maybe a buffer zone inside the arena to make sure that we don't have any real bad issues to start with. Maybe a sound lock configuration for the entrance area, etc. The third issue is the geometry, which also I can relate to your presentation again, Klaus. Was mentioned. We don't want any overly concave roof shapes or parallel hard surfaces because we're going to have echoes and reverberation, and that's exactly what we don't want, as I had just tried to explain. So fourth point is specify surface materials. What do we have in terms of fabric, wood, perforations, metal, stretch metal, etc., etc. And I also put in the keyword of electroacoustic enhancement, because that would be a means to, with a loudspeaker system, create some reverberation inside the space that is then not created by the materials but by an electronic algorithm and loudspeakers that will replay a certain amount of reverberation within the space. Fifth here is the acoustical modeling, a very interesting and cool step. In the computer we have the architectural model is taking and changing to an acoustic model, and we do some predictions on the parameters that have been set in the target case at very early at the start of the project, and we're going to make sure that we hit the benchmark. We are actually going to be good enough in terms of acoustics. This often means that we're not, so we need to go back and change something on the room geometry, or then go up the stairs again here, change some materials, or maybe change something on the shape of the building, that we actually do hit the target that we set at the beginning. If construction starts, we have another slide for that, my last slide for today. This is the architectural integration. Once we found out in the modeling what we need, what materials, what geometry, we actually have to tell the architect, so please do this and do that, and then there's a lot of coordination, because the architect may not at the beginning like what we have in mind, so we have to make sure that we get to an understanding that still the architectural vision is upheld, which is really important. Then the design development specification, often there will be acoustic performance data in the tenders that go out to the companies that are actually going to build this, like for the roof or for the wall or for the seats, etc. We need to make sure that that is all in line with what we expect. Then construction monitoring, very critical step. Many steps actually in most cases, because it's a long time. We need to make sure that this is all put in place in the right way. Maybe some measurements in the meantime, maybe some controls of materials, maybe some lab testing of materials, substitutions. There will also always be, okay, we take this instead of that, maybe yes, maybe not, etc. Then second to last step is the commissioning and final verification, which is another site visit, making sure that the acoustic targets are met by the final deliverable project. So we have to document that, making sure that the legal thresholds are met, for example, fire safety, speech intelligibility, but also level distribution within the space, that is all in green. And the last step is the handover documentation for the client. We have a kind of a report that summarizes the system, the acoustics of the place, and also often can be used by companies that come in, like a sound company, to make a touring show. So they can maybe use some of the components that we've installed, some of the acoustics that are installed, so they understand. Maybe it's an acoustic model that they can use to design their system for their tour. That's the thinking of that last kind of step. That concludes my part, and I hope I gave you enough keywords, Dominika, to fill in here with some more specific equipment-based and electroacoustic-based elements. If you want to go ahead, please.
Absolutely. Thank you very much, Dirk. That was excellent. And I really like the overlap between the sessions, between our presentations. So there is plenty of things to refer to. So let me put up my screen. So let's go.
There we go. Looks good.
All right. Excellent. So we are still talking about the design for multipurpose arenas and the stadia, but we are now putting loudspeakers into the venue. So the critical part, the part that makes actual signal go very loud, because as we all know, the crowd noise is just taken for granted. It just belongs to the space. And this is why there is a huge responsibility on the loudspeaker manufacturer to control what is happening outside of the speaker. A little recap, or both Klaus and Dirk, you were referencing to different kind of content that is being brought to the modern venues, be it construction projects, be it retrofits around the world. So those venues are designed basically to facilitate very diverse content. That could be a soccer game today, that could be a concert tomorrow, let alone the comparison between soccer and NFL. This is very different event dynamic, very different physical setting too. And there is a huge expectations for the installed system to be able to reproduce any kind of the content without any need for supplying another cabinets or redesigning the whole concept that was once delivered. Venues are not only built for versatile content, but also to enhance the sports culture. So they are designed to bring community together and to bring people on the same mission of enhancing the sports culture, especially for the young people, but also across the generations. That says the modern venues will be brought into the communities, so be it in the middle of the city or just being accessible and maybe eventually becoming a landmark statue for the city, maybe even evolving into becoming sports districts, just like a future Benfica sports district in Lisbon. Those location choices are dictated by the concept of the operation. But in the end, in our case, the sound system must just fit to that. It must adapt to what is given the building concept. And in the end, it's not only about the maybe sound pollutions, like the annoyance to human ears. Maybe it's also about the wildlife. I've had an inspiring conversation lately about that, protection of the environment. And speaking of environment, the increased trends on sustainability. So we see non-standard material choices in the buildings, like stadia. That impacts reverberation. That impacts weight allowances in the room. We also see increased use of the daylight in the stadia. That means, maybe you could say it's not entirely irrelevant for us, but that means you would expect an open roof or an open building in a larger aspect than you would expect, than you would have to work with. That all paints the big picture that the sound system designer needs to be aware of. to treat the venue holistically. And in the end, we have a very narrow part to fit inside, which is the loudspeakers. Now, how many of you participated in a project that was entirely focused around perfect positions, perfect system layout of electroacoustical system? Now, maybe if I ask about acoustics, there is a selection of projects around the world. So obviously performing arts, opera houses, but also arenas and the stadia, possibly, that is slowly changing, but never around the electroacoustics. So if you are about to put the speakers into the room, which is a sports stadium, your first question should be, where can I place them? What is the position allowed? What are the weight allowances? What are the rigging possibilities? And then you will discover that shrinks the options to minimum, to just a few, if at all. If there is a small flexibility to it, you would be very lucky. But most probably there will be just a couple of just one possible position that you just have to work with. And there is a good reason for it, I guess, because the truth is we will always lose over visual enhancement systems, over LED screens, over advertising spaces, over the sidelines to the pitch, to the stage, to wherever the action takes place. And we have a difficult mission to explain why is that relevant to really work on direct SPL distribution, because yeah, simple fact as it is, loudspeakers are producing something that we can see. So with LED screens, with the sidelines, it is very easy to justify, okay, it needs to be like this. We need to ensure that you can see it. But with sound, you have to translate it. So you could say it's a little bit like with the temperature. You cannot see it, but yet you can see the heat maps and different other parameters on the map. But it's a kind of interpretation. And even if you manage to put it on the screen, on the map, with temperature, there is a difference between felt and measured. So you could say this is very difficult topic to make data-driven decision. But there is a bunch of data that we could use and we should be using. So once we have the positions determined, we make sure that we make use of the cabinet specifics. So the way that they were designed to reproduce the content, directivity patterns, different processing that is inside. This is all the information that we see on the direct SPL coverage plots. That is obviously not enough, because as you may appreciate, there is never a chance to really hear direct sound in real life unless we are in anechoic chamber. That's obviously not the case in our specific topic. However, that gives you a very good basis for the considerations. And then what should be considered? So to color the plot, that seems to be an easy mission. And yeah, you could say this is the target. But then you can extract a bunch of statistical data from it. And these are numbers, yes, but they need a correct interpretation. So to do that, we all have experience, we are sharing experience, but I would say we must have a good guideline. That guideline, hopefully, is included in the project brief, wherever it comes from. So let's say I think most of my peers in the industry and the sound system design enthusiasts came across that number, 105 dBA for a stadium. Now, is that specific enough? Does it tell us what we should be looking for in the statistical consideration? Not quite. To show you how this should look like, this is really the entire context to this 105 dB. What you can see on the screen is a part of the FIFA Stadium Sound Reinforcement System specification put together by industry experts Martin Reich and Anselm Götz. That is obviously not all of it. It is only a part considering maximum sound pressure level. This is 20-something pages document that covers the methodology very comprehensively, and it covers also the requirements that must be reached. It may appear complex, it may appear hard to interpret, but once you can see that it really comes down to 4 main aspects, it is really getting a lot more easier to interpret the whole thing. So those 4 aspects will be ultimately the value, the parameter, the exciter signal, and the room conditions. So the value, I mean how much, so what is the desired SPL or STI? Is it 105, 108? But that means nothing without the context of the parameter. Are we looking at the average value? At the average value for 90% best results, or a minimum value, a maximum value? I've never seen a specification that specified desired maximum value. It is mostly in that domain that I already mentioned. And then exciter signal, that describes which stimulus should be used for the test. And there is quite a few of them to choose depending on the test, on the method. And then the 4th aspect, room conditions. So this is the time where we bring the room as an integral part of the sound system. Yeah, so it's really that maybe in smaller venues, we don't expect the acoustics to work against us. Yeah, it could happen as well. But in a stadium, you can really expect that it will work a little bit against of what we are trying to achieve. Then it becomes vital to understand what's happening in the room. And you could say it's a little bit like VAR system for our purposes. So you look very closely, you look from different angles, you probably have a bunch of people analyzing the same thing. Ultimately, there is one that makes a decision, okay, this is what's happening and this is how we address that. Why is that so important in a stadium environment of pronounced acoustics, let's say? Because when we look at those 2 curves alone, which represent the RT60 curve between the occupied venue on the left side and the empty venue on the right side, you could already see how much difference does it bring to only replace one material in the room. So from publicum, from the spectators, to concrete or to empty seats, and that changes the acoustical environment dramatically. And I don't mean it ends up dramatic, it's just a dramatic, massive change. And this is only one material that changed between those 2 versions. And maybe this is not the only thing that is changing between the scenarios. Maybe we have a retractable roof that changes the conditions of the ceiling. Maybe we have adjustable seating areas, yeah, not very uncommon, also in very large venues. And maybe we're looking at the rotatable arrays. Maybe we designed the system the way that it also serves as a ring delay for a musical production, and then there is a certain setting that addresses that. Also, different system behavior, both in occupied or unoccupied venue. And we make sure that we examine those different scenarios because in the end, yes, we have processing tools on site. Yes, when we go to commissioning, we do that, but we must remember or be mindful of the fact that this is not a rescue, and this should be a refinement tool. So whatever you can be prepared for, this only plays to your advantage. It makes everyone's lives easier, starting with the man operating the microphone and the measurement system. So always make sure that you examine all the scenarios and make sure that you follow the recommended method, because there are also different testing methods, also in the simulation domain, that is really vital to make sure that everyone is following the same path. So instead of a magic formula, where to put your system, how to examine it without the context, how to color the plot, and how to make a good documentation out of it, we discussed the understanding of importance and consequences of the system layout choices. That is difficult enough. Of the sound system performance evaluation, Dirk was talking a lot about that and the excellent explanation. a little bit about the context to data presentation that is really important to understand. And last but not least, understanding the venue acoustics as an integral part of the sound system, because we are never playing alone. This is not free field condition. This is very particular field conditions that we need to adapt to. Why is that so important? We are discussing sound system designs across the manufacturers, across the system concepts. And obviously we all have different USPs, we have different technologies behind, we have different maybe even philosophies to the cabinet construction, to the whole concept. So yes, during the comparison, those results will have a certain flavor. Yes, this is unavoidable. But what is important for us is to stay within the same context, because if that goes sideways, then the discussion is not only not fair, but also pretty useless. This is why data interpretation and specification is so important in our industry. My key message to everyone that is looking after sound system design for large-scale multi-purpose objects, Dirk was putting together a very comprehensive list of steps, which I adore. My message is a little bit simpler. If you want to go fast, go alone. If you want to go far, go together. Always discuss, make sure we're on the same page. Different providers, we're aligning with the client's expectations and with the industry standards. So by standard, I mean something that we can measure, so we can make data-driven decisions and that are based on a deep understanding of everyone's expertise. And on the way, hopefully we have a lot of fun with that, because we are looking at speakers. Hey, this is super cool aspect of the entertainment and of the live experience, at least in 2026. Maybe it goes towards a different direction in the future, but we will always belong to the experience. That said, thank you very much. Looking forward to the discussion. Thank you, my fellow panelists. That was excellent.
Thank you very much, Dominika. You can, yes, end your sharing. You did there. Time is running, so we will quickly go to the discussion part of this. And Klaus, I have a question for you, and Dirk also, which you kind of took care of in the comments, but I would like to ask it for Klaus as well. There's a question from Neil Woodger, who's saying that equally important to acoustical quality and flexibility inside multipurpose arenas is the issue of keeping sound inside the building. Have you had to integrate any specific roof upper requirements into your arena designs to contain sound?
For sure. I mean, again, depending on the situation. Actually, I worked together with Neil on a project for the Copenhagen arena that became the Royal Arena, and that was very close to the airport. So that was, of course, one of the issues about how do you actually deal with the exterior sound, but it was also a new residential area. So again, you need to contain the sound within the box itself. So again, that's why it's so important that you have, the experts on, the same around the same table in order to deal with aspects like that. In the Bergen Arena, which Neil is actually also part of, when hopefully we start to the more sort of detailed phase of that, there was supposed to be a sort of rescue helicopter or heliport just next to the arena. Now luckily they changed that decision, but that would have been an aspect as well. So of course it's not just to create the great sort of acoustical experience within the space, it's also controlling the whole sort of, I think you, Dirk, also mentioned sound blocks, things like that is of course critical points in an arena as well. So yeah.
Thanks, Klaus. And I have a question for you, Dirk, and perhaps also for you, Dominika. From David Thomas, who's asking how you introduce the effect of the loudspeaker design. Maybe you want to go first, Dirk. There's some different tools that you use, and maybe you want to share a bit about that.
Yes, absolutely. We use several simulation tools. One of them is Ease, one of them is CAT, which both allow the room acoustic simulation as well as also putting speakers inside the space. And I also made a quick comment that it's absolutely audible even for lay people to determine sound quality differences. I'm not going to say the simulation is 100% accurate with reality. That's not really the case in most cases. But the relative changes from system A to B to C, or also system A and A1 and A2 with maybe more speakers or a different distribution, that is absolutely audible and is well represented A in the data that is being put out by these programs, and B also by the audioization files that are files you can actually listen to in your headphones or an acoustic lab environment like we have in our offices. But Dominika, you probably share the same kind of experience or have a different opinion?
Yeah, absolutely. Absolutely. I can only emphasize that accuracy in terms of the experience later, that heavily depends on the accuracy in modeling. So it takes two, about acoustical modeling and geometrical, the quality of the model, how realistic is that compared to what we have in real life. And then the second, not less important ingredient is the electroacoustical data of the loudspeakers. So how accurately are they measured and how truthfully do they represent the speaker behavior and the processing on top of that.
Great, thank you very much. I have a question from Anders Jørgensen. Maybe this is most for you, Klaus. He's commenting about the Avicii Arena. Would you be able to tell about the active acoustic system that use microphones, speakers, and DSP power to change the acoustics at Avicii Arena for speech enhancement during sports, and the reason for adding this huge system? I hope that makes sense.
Yeah, I think for the first part, I'm not the right one person to answer that question, but I can say that there's a Møller sound system that is integrated, and there's a company called Stauenburg, who was the sort of the technical part of that. So I think, they would be very happy, I'm sure, to share the more technical detail.
I can share that he is actually from Stauenburg. So I think
that's the reason. Yeah. but they, then he knows the answer. But because they did a great job there, and it's so advanced that I think it's only the experts that can actually explain that. But the other thing about the reason for doing such a huge thing, of course, there's the acoustical part of it, but one has to remember that, in the old Avicii Arena, there was 85 meters to the ceiling. There was, of course, a rigging structure, but it was not that flexible. That was hanging in the middle. With this new system, you have actually, like you would have in a new designed arena, often you would have a roof structure where you could actually use that as a rigging sort of floor, or so to speak. So with this new sort of ceiling that is placed within the middle of the sphere, you actually also have a very flexible rigging structure. So you could say that is part of why it's such a big structure. It's because it's not just solving one thing, it's actually solving several things. And the reason why is because the need and demand for flexibility in an arena like the Avicii is huge. And I can say that it's already so that the client, the people who runs the Avicii Arena, they experience a huge sort of extra demand for having musical events within the arena, because now the experience for the audience is so much better. So there's an ego from both performers, but also from the audience to have even more. And that's part of the business model.
That's great. Thank you. I have a question. Lots of questions coming in. I don't think we'll be able to take all of them today. We'll need to do an encore someday. But there's a question from Daniel Choi. Aside from the obvious differences of applying absorption to the underside of roof surfaces, what other considerations do you have for both acoustics and AV system design when comparing an enclosed stadium versus an open stadium design? I don't know, maybe you, Dominika, want to start with that one? If you have an answer?
Yeah, why not? Let me read the question again.
Maybe you, Dirk, you can chime in.
Yes, I think acoustically, well, you never really reach the absorption of an open roof with any surface. Unfortunately, it would be very nice to have 100% absorption in all the frequency bands. If it goes out, nothing comes ever come back. But you introduce a major structural isolation acoustic issue with an open roof. The neighborhood will, without really careful consideration, will hear pretty much everything that happens in the space. So it has a huge implication for like opening hours, the number of events per year you can do, things like that. That needs to be carefully considered if that's really what you like to achieve in the space, or if it's better. Like Klaus showed, that's of course really big budget numbers, but have the thing with the closure. A couple of stadiums have that, and it also has some weather implications, but absolutely also has some acoustic advantages for the usage of the space. If you want to have a rock concert 25 times a year at 11 o'clock at night, you better be sure that no neighbor's going to complain. But Dominika, maybe you want to expand on that. Maybe also directional.
That's what I'm about to say, really, because yes, you cannot really control the absorption coefficient of the open roof. Yeah, like you say, would be nice, but unfortunately, so if you're lucky as I am, if you work for DNB Audiotechnik, then you can very precise directivity control embedded into the cabinet design, so you don't have much to worry about. Obviously, there is a bunch of other things that you would have to worry. Like I mentioned, we're not only talking about the long reverberation, but also long echoes and things like this, pretty unpredictable things, or predictable to an extent. But as much you can control from the cabinet design alone, or the system concept, that is then playing to your advantage. And directivity control, both in the horizontal and vertical plane, is one of that. Then obviously consideration for different frequency bands, top cabinets, subwoofers as well, the critical band for the annoyance level, let me put it like this. This is what we are working on at the stage of designing the cabinet.
Great, thank you. Another question from Daniel Vargas, I think mostly for Dirk and Klaus. For stadium designs with enclosed or semi-enclosed cavities below the grandstands, how should these spaces be evaluated acoustically in terms of cavity resonance, model behavior, low frequency amplification, and potential coupling with the main bowl? Based on your experience, what mitigation strategies are typically most effective?
I think, Dirk, this is for you to answer.
Okay, I was afraid you were going to say that. This is not an easy one. This is actually pretty complicated. I think main point is we try to avoid having those zones, low overhangs, not like huge balconies that you have to control the space below. Mostly it's kind of possible to have that. Not always though. It's really heavily custom. Then we get to the BEM, BM, FEM boundary element methods, calculations of low frequency behavior. That gets very complicated very quickly. We have like a rule of thumb that the balcony, the lean out can be max half of the height of the balcony. So to prevent exactly that, what this gentleman is pointing to. So we try, I guess the best answer is to try to avoid it. If really not avoidable, it's really a custom solution. Often we apply absorption at the underside of the balcony. There's sometimes even additional sound sources in those zones to make sure that the level of the sound gets there. We still want the directional cue from the stage. So the first wavefront comes from the stage, but then afterward we have some increased level by additional systems in the under balcony zone. It's really not a very satisfying answer, I'm afraid.
But I think also maybe to add to that, it is something that when you're designing the arena, seen from the architectural point of view, and you get the brief, there's often a wish for a certain amount of seat, and often that is really tricky to actually create, the bowl design in a way where you get all the seats that people want without creating actually acoustical problems. So I think that's again why the ball design, and the gentleman that asked the question before, Neil Woodger, he has really pushed me through a lot of iterations of sections. So I know for sure that is something that one should, from a starting point, try to avoid. In the Avicii arena, there is actually with the new gondolas, there's a huge sort of place underneath that where there's actually audience sitting, but that surface below the gondolas is also treated very carefully with both something that would diverse the sound that comes into the area, but also absorb. So it's a combination of that to break it down and also to absorb it.
Thanks, Klaus. Final question for today from Fabian. This one's for you, Dominika. How do you draw the line between speakers for sports and those for live events? To what extent does the venue's sound system become obsolete for live shows?
Yeah, good question. Very easy answer, at least in my case. Application draws the line, not loudspeakers. Obviously, no one wants to compare studio monitors and line arrays. So I am assuming that we are talking about the reasonable comparisons. But the assumption or the expectation is that there must be a system that fits all those purposes that we discussed. That it fits rock show, that it fits halftime show, that it fits speech worship event. Yeah, it must be able to reproduce that. And in 2026, we have systems versatile enough that can be on that mission. So, yeah, again, I would emphasize that we are drawing the line more in the application domain, not in a speaker model.
Thank you, Dominika, and big thanks to Klaus, Dominika, and Dirk for joining today's webinar. Thank you to all of you signing up. We were, I think, 230 registrants for today's panel. So thank you so much for showing your interest in the Danish Sound Cluster community. If you're into sports and if you're into audio, please sign up for our next week's webinar where we're inviting some broadcasting experts to dive into sound production. This one will be in Danish though, but you can get subtitles in English. Our next sound discovery, which is a physical network event, will be at TV2 Denmark. This is a new field in film production where all film and movies needs to be with audio description for those who can't see. And we have AES convention coming up, which will this year for the third time ever, will be back in Denmark. It's at DTU at Copenhagen. If you are planning to go and you want to meet up, you can write me and let's have a coffee. And we have also our sound discovery at the legendary Medley Studio with Søren Andersen and some industry players. And yeah, please check that out as well. If you are interested in the Danish Sound Cluster community, if you want to join us, you can go to our website, danishsoundcluster.dk. And we are also on Instagram, we are on LinkedIn, and we are on YouTube, where this webinar will be published as soon as I get the recording from Zoom. And so please keep an eye on that. And with that being said, I would just like to say thank you once again, and hope to see you some other time. Bye.
Thank you very much.
Bye.
Wonderful day, everybody. Bye-bye. Take care.